Now we are going to see some new subtopic. It's called anti-normalisation. Some people call it the anti. This is the process of now, in our usual cases, they are giving us this value of z, then we are getting this probability here. But now the case we are going to see is, now they are going to give us this probability, and then they ask us to get this z value that is giving us that probability. That's what they call the anti-normalisation. It's a process of obtaining z, given its probability p. But I want to call something that whenever we have from 0 up to here, from 0, this is now the normal, standard normal, where I mean is 0 up to here. So if you have from here up to here, we call this one P. Also from here up to negative ZP, we call it P. Now, remember we said that if it's normally distributed and it's the standard, the whole area and the curve is 1. So it means that they say that this one is always symmetric at 0, meaning that this side is equal to this side. So this is 0.5 and this is 0.5. Now, if this probability is P, it means that this remaining one from here, where this side will be 0.5 minus P. Even this one, if this is P, remember the other side from here to here is 0.5. This will be 0.5 minus P. And also note that as ZP, as this ZP tends to positive infinity, this probability will tend to 0.5. Why? As we extend from here up to this side, the probability we are tending to is 0.5 because the whole of this is 0.5. So that's it. Now we are going to see how we get the value of this z given this. So if z, this shows is standard normal. Why? Because mean is 0 and variance or the standard deviation is 1. Find ZP. Now here they are giving us from 0 to ZP. I think we said from 0 to ZP, we said that is always equal to P. So now this is our probability. Now they want us to get this value of Z. There, we just go into our table of probabilities there. Now there are two ways here. So when you come to this, you see now, I'm going to, now for these values which are perfect, these are what I'm calling perfect values. These ones, you see that this is our P, the probability. These values are perfect. They are 0.5, 1, 1.5. So for these ones, if you have them, you just come and look them. The Z value is there. It's that the values of Z is there. So now there they are giving us 0.15. When I look for 0.15, I think you see a value of 1.5 there. I think you can see it. The Z value is 0.385. So meaning here, the whole of this now, my P, this P, from here up to here, this P now, I have it as 0.15, because this is my P. Now my ZP, we have seen, is 0.385, and that's how we get that. Now when we come to these illustrations are going to be very important. So this one is telling us Z less ZP 0.8. Now 0.8, you see, inside from here up here 0.8, 0.5, and from here up here 0.5. So if something is our ZP is here, our ZP is here, less than 0.5, it means that it's exceeding 0.5, meaning it's going to be beyond even this, because this is 0.5. So to be 0.8 is exceeding even this. So that's how our ZP is. Now we want the whole of that. But you know that from here up to here, remember that this is our P. So we are looking for this P here. But you know that this is 0.5. But they are giving us the whole probability from here up to here. We shall get 0.5 then plus this. And they are giving us that the whole of that is 0.5. So remember that this one, now I'll say 0.5 plus this P, the whole of it, they are giving me that is equaling to 0.8. How am I getting this? Because you know that, hopefully remember, this one is saying from Z less ZP will be 0.5 plus P. Hope remember that we get this, then plus this P here. Now, they are giving us all of this as 0.8. Now we need this P. So that we always need this P This P is what we read from the tables. So that's why I'm interested in P so much. So if I make it a subject, so my P here will be 0.8 minus 0.5. And so my P is going to be 0.3. If my P is 0.3, now I need this Z value of P. I'm looking for now this. Now, how do we read it? I go in the table, then I read for 0.3. How do you look for it? You can, now that one is also a perfect value. You see hour is a perfect value, 0.3. I think you see there. Then you just read the corresponding value there of Z, if I'm to do it for you there. I think we see the value I'm getting there. 0.842. This is the P. Then this one is our Z I'm looking for. 0.842. As simple as that. So that's it now, members. Now, or we can also go through this table and read that value properly clear. Let me show you how we can do that. Anyway, let us do it in this next example here. Now, this one they're telling us that ZP is less than ZP. But now, here you have to be careful. When you look at this probability is very, very small. If it was this case, remember this is already 0.5. So this one is expected to be, if it was here, we would expect this to be beyond 0.5, but it's less than 0.5. Meaning that now what comes into your mind, it was something which was this side B. So implying that this was a negative ZP. Why am I concluding like that? Because this probability, it can't be here, because if it's here, it has to be at least greater than 0.5. Because if it was this case, we say that from here to here is 0.5, then plus this. So, but this one is below 0.5. So meaning it wasn't here. It was this side, but this side will only have negative. So this was the case, less than this. Now here it means that we say that this one, the whole of this one, is this value here. So now we are interested in this, but we say this one is 0.5, so now they are giving us this. But remember now our Z is going to be negative. So meaning, but we say that this one is 0.5 minus P, if this is our P. We are interested in P. So the whole of this we say remember, we said the probability of Z less ZP, this side, is going to be now, when you have it to this side, it's going to be the probability of 0.5 minus the P. Now they are giving us this minus P. Now this is our probability 0.0793. So that from there, our P, if you subtract off that, you get your calculator, and then our P is going to be 0.0793. So the value of P I'm getting here is 0.4207. Now this value, my ZP, is going to be now negative because it was this side D. Hope you get that. Or you can just ignore and then you say, I'm looking for this value Z. Then you put there your negative. Then you are free to ignore this like this. Because you are looking for this negative. Now we come. This one now we are looking at it in the table because it's not the perfect one. So look at this. How are we looking for it? Now you see that is 0.427. I can't now read it from here because it's not anywhere. Now that one, we have to use the table. Now from there, we move to our cumulative. Now you come to the cumulative normal. This is where you are going to look for that value. Now because that one is a probability, now we look, I hope you see, these are probabilities of Z. Hope you see that, probabilities of Z. So I'm looking for value for 4207. So here I look for 4207, a value close to that. 4207, I think 42, where is it? I think we see it, the value is there. You see that value? 4207. It's what I'm looking for. But it's under what? You see, it's 1.4. Then this one is under 1. So it's going to be, the Z here is going to be 1.4. Then we add on this one. So now there our Z is going to be 1.4. But you see that 1.4 is under a 1. So here our ZP will be now negative. It's divided through by that 4, 1, and that will be our ZP. This one is the same idea with this, the same. So that this one is bigger than 0.5. So this ZP will be here. Then you look for that, the same idea here. Now let me focus on this. This one, so we have Z greater than this. You see it's 0.5. So now it means that it was here. Because if it's greater than 0.5, the whole of this is 0.5. Now this one is our ZP we are looking for. But you said if you have that case, so here, remember I said our ZP, in that case, we shall get P, then we subtract off, we said if this is our P, that is our P, we said we shall get 0.5, then we subtract off that. So here we shall get 0.5, then minus this P, so that we can get this. But now they are giving us the whole of this. It's now 0.5 minus P is 0.3802. If we make P the subject, so our P will be, if we make it the subject, the answer we are getting there is 0.5 minus 0.3802. The answer I'm getting there is 0.1198. Now I'm looking for this P. So now my ZP here, we are going to be a little bit careful here. You come into the table. You come into our table. Then, when we are in our table, you look for that value 1198. Because it's not perfect, so we go to these ones of the cumulative. So, the value of 1198, 1198. So where is it? So you see that it would be between this and this. So 11 is here, but we want 1198, which is not here, but it's between between this and this. Now what we do here, we subtract off and we see which one is having a big difference. So this is what I did here. Hope you are going to be able to see it here. Now, when I got a difference between the value I want, I think you see the value I want is there. Remember this one I don't have in this one place, so I also treated that as 1198. And I subtract off this value here. I think it's 1179 here. I see the difference is 19. Then when I get this and I subtract this, the difference is also 19. So they are the same. Now, which one reached there faster? You see that this one is, we take now this one, if the difference is the same. Now we take this one, because this one is yet to reach that one, then this one which passed it, this one starts beyond 1198. So we take this. But now this one, when we take it, it's 1179. But we have, it's not yet to 119. So it's this now under 0. So we have 0.3 under 0. So we need, how many do we need to add? We need to add 19. When you add 19 to this, we'll get this. Now we come this side on add, we move. We said that now we want to add 19. Which value is having 19? You said this is the value. Now it's under 5. So it's going to be now 0.3 under 0. Then we are adding, we are adding under 5, which is the 19. The difference we got. So there, the value is going to be 0.3. It was, the value we used here was 1179. 1179 was under 0, but we are adding 19 so that it gets us to 1198. but this 19 is under a 5, and so that will be our value of P. When I come to this, you see that this one is also greater, but this greater can't be here. Why? Because this one is already exceeding 0.5, because we said this is 0.5, so this probably can never exceed 0.5, so it can't be here, because these values which are here, they should always be less than 0.5, so it means it was this side B, so it was now negative ZB, because if I get the whole of this, that's when I will exceed 0.5, because this is already 0.5, then plus this, that's when I get a value similar to that, and it's greater, that's why I'm shading greater like this. But we say that value, if it's the negative, we say that the probability of this Z greater than the magnitude of ZP will be always 0.5, this 0.5 plus this P. We say that this one is P, so plus this P. So they are giving us this, which is here. So mean that now our 0.5 plus P is 0.7362. When we subtract, our P will be 0.2362. Now here, so our Z is negative. So our negative Z here, P, is going to be, now we read this from the table. So now we are looking for 2362. So you come to your table, 2362, something close to that. 2, 3, where do we have 2, 3? It's 2, 3, 6, 2. 2, 3, 2, 3. So it's that it's between this and this. It's between this 2, because there we have 2, 3. So 2, 3 is here, it's between this and this, but that one is 62. You see that here, we have this value 227. So our value is between, let me write it for you. It's between, so the value here we are getting is 227, 2. So if I'm writing those values for you, I think you see, yeah, the ones we need, what we need is 2362. This is what we need. But what we have here, I'm seeing that it's the one which is close to this is 2, 3, then 5, this one, 2, 3, where is it, sorry? This one, 2, 3, 5, 7, and this one, 2, 3, 8, 9. Now you see which one is closer to this value. You see that this one is closer. So this one is closer to this. So meaning by what difference? You get 2, 3, now 6, 2, minus 2, 3, 5, 7, and instead the difference is just a 5. Now, you see that when you get this, or when you subtract this from the one we are looking for, 3, 6, 2, the difference is, you get your calculator there, the difference is 2, 3, 2, 3. Here the difference is 27. So here the difference is that the difference here we get is 27, and this one is 5. So we take this one because it's closer. And now this one we need now to add. So this value is that this value we've got is 0.6. It's for 0.6 under. Is that it's under 3. Then we need to add a 5. So then you move, we need to add a 5. Where are we adding a 5? So the 5 is not there. So our 5 is that it's not there. 3. So this is that now we need to add. We need to add here 5, but it's that our 5 is not there. So you have a 6. 6 is that this is 3. To reach a 5 there is 2. But this one to reach a 5 there is this one, the difference here is 1. The difference here is, I think that the difference here is 3. So now we take this one of 3. So that's why I'm going to take this one of 3, because this one has not reached it yet. So my answer is going to be that. Okay, so this one is going to be 0.6 3. So 3 minus ZP will be now negative 0.633. What about this? Now that this one is modulus. So, and you said modulus of Z less ZP, then it's the same as modulus of P less Z less ZP. So here meaning we have now negative ZP, and this one is negative and then positive ZP. So now we want this probability here. And we say this is P, and also this is P. And we said from there, I think we recall that always our Z modulus ZP will be equal to 0 and then 2P. So now they are giving us here. This is so our 2P is 0.9. So our P becomes 0.45. Now this one is a perfect value. So our Z P now is a perfect value. Why am I calling it perfect? Because frankly you can read it from the critical. So that when I come to that is perfect value. So now I come to the critical. You say I'm looking for P, which is 0.45. P, which is 0.45. I think you see it, it's there. The value is 1.645. 1.645. So that's it, members. That's how we get these ones. Now we are going to see how we apply these ones. I wish you well. Remember, sorry about this. This is supposed to be 2 because we are adding. This is supposed to be 2. This is 2, not 3. This is 2, but we are not getting as to why. Because we said in that difference, let me come back and explain that. We said the difference we had here, the difference was 5. And when you come to this table, is that this one you have 5, but this one is 5 to 6, but this one you have 3, 4, 5. So this one is closer. So we will add a 6, but 6 is under a 2. That's why that is 2. So that's why we are adding this 2 here. So that's it.